And we're going to start reviewing. Okay, are we ready? So, we know what our test is going to look like, right? So it'll look just like this. So we're going to have a page of problems that says solve, but the method is going to be very specific, just like it was on your quiz. So the first method is substitution. If you don't do substitution, you're not going to get any credit for the problem. Okay? So make sure you're doing the right procedure. What does substitution mean? What do I need to do if I'm going to substitute? I got to get one letter by itself. So here I might say x equals 7 minus 2y. And then I take the 7 minus 2y and I plug it in for this x right here. So I'll have 2 times 7 minus 2y minus y equals 4. Is everybody okay with that?
Yep.
So 14 minus 4y minus y equals 4. Doing distributive. Now what?
Put the y's together.
Put the y's together, collect right terms. So 14 minus 5y equals 4.
Then you subtract 14.
Subtract 14. So negative 5y, don't forget about that negative right here. Negative 5y equals negative 10. And y equals positive 2, right? Positive 2. Now you aren't done, because what you put in the answer blank, and I don't see an answer blank there, but what you would put in the answer blank is an ordered pair with y being 2. So what do? Put the 2 back in, and you can put it back in wherever you want to put it back in. Just put it in somewhere. I'm going to put it right here, because that'll tell me what x is right off the bat. So if I put a 2 in there for y, I'm going to have 7 minus 4, which is 3. So the answer to the problem is 3, 2. Everybody remember that? All right, now the next problem looks exactly the same kind of situation here, except the directions say you must use elimination. All right, so gather your thoughts. What do we do when we eliminate? Well, we got to make either these two the same or these two the same, right? Might be easier to make the y's match.
Yep.
You could do either one, but it might be easier to do that. So 2x plus 3y equals 4 is my first equation. And 9x minus 3y equals negative 15 is my second equation. Remember, when you're multiplying by 3, it's everything by 3. Okay? Now, add straight down. So this is going to make 11x. These are eliminated, and negative 11. So x equals negative 1. So just like before, though, your answer is going to be an ordered pair and this time the x coordinate is -1. And just like before, we go back to the beginning, and we put in -1 somewhere. So if I put it in the top equation, it doesn't matter where you put it in somewhere. If I put it in the top equation, I'll have -2 plus 3y equals 4. So if I add 2 to both sides, I'll have 3y equals 6. So y is 2. Got it? All right, and then the third problem, same kind of situation, but we're using what you did on your quiz, and hopefully you did it correctly on your quiz. We're doing Kramer's rule. All right, so let's review the steps. What are the steps to Kramer's rule? Find the determinant of my coefficients. So the x and y numbers. So that determinant is 2, -4, 3, 2. Is that okay with everybody? Now what is the value of that determinant?
16.
Multiply, multiply, and subtract. Ethan is exactly right, it's 16. Does everybody get 16? We need to make sure. All right. What we're gonna do with that 16 now? Where does that go? That's the denominator. So your answer is an ordered pair, just like these last two, but this time they're going to be fractions, because I didn't rig the problem. At least I don't think I did. 16 is the denominator. All right, so here we go. Now I have to find my x and my y for the numerator. So they are determinants also. And now is when these numbers come into play. I haven't used these yet. So remember what I do? What do? Cut these out and put them in the x column. And then cut them out and put them in the y column. So when I put them in the x column, my y's stay right there. When I put them in the y column, my x's stay right there. Nothing changes order. This is still x and y. All right, so what's this one? 2 minus 8. I multiply these, I get 2. I multiply these, I get 8. 2 minus 8, -6. This one is going to be -7, -4, and 3, but I gotta subtract. -7. Now, if they reduce, you gotta reduce them. I can't remember, I just did all the quizzes. Did any of those reduce?
Yes.
Did
No,
one
no,
did?
not, oh, on the quiz, sorry, no.
So we got -3/8 and -7/16 as our final answer. Everybody okay? All right, now, remember, this is what your test looks like. Kids, there's a whole week in between now and when they see each other again. But we're gonna keep on reviewing a couple days after we get back, and then we're gonna take our test. But your test is gonna have a page of problems like we just did. Substitution, elimination, Kramer's rules. Then you're gonna have a whole page of matrix operations. Okay, so let's see if we remember how to do this. What would 2a look like? What does that mean I do? Anybody remember?
Do 2 times the brackets of that.
2 times every number in A, so it's like a distributed problem. So top row will be 246, negative 220, 0, and 062. Is that okay with everybody? We just simply take whatever the number is. It may not be a 2, but whatever it is, take it times every number in the matrix. Okay? Easy enough. All right, B minus C. Now, it's been a while since we did these things, but you remember sometimes we get no solution. So first thing you gotta ask yourself is this a doable problem? It's always doable to multiply by number. You can always do that. But it's not always doable to subtract. Is this one doable to subtract?
Yeah.
Yes, because,
Squares.
well, it's not that they're squares, it's that they're the same dimensions. They're both 2 by 2. If they were both 2 by 3, I could still subtract. They have to have the same dimensions. So then how do I do it?
Don't you subtract the same spots?
Same spots. So 1 minus negative 1. 1 minus negative 1 is
2.
negative 1 minus 1.
0.
Oh, be careful.
No, negative.
Negative 1 minus 1 would be negative 2, isn't it? 2 minus 0.
2.
3 minus 2.
4.
All right, does everybody remember how to subtract matrices now? All right, next, A plus B. How do I do A plus B? You can't. We just talked about it. Why can't I do A plus B? They're not the same size. So just empty set and move on. Your test will have some empty sets on it. All right, D times A. All right, D is this. And A look, it's not mine, I know. Okay. D times A. What are the dimensions of matrix D?
2 by 3.
2 by 3. You gotta get that right. Does everybody see the dimensions are 2 rows, 3 columns? What are the dimensions of this matrix?
3 by 3.
This is a 3 by 3. Can these be multiplied?
Yes.
Yes. Remember that rule that the inside dimensions have to match?
And it would be 2 by 3.
And when I multiply them, I will end up with another 2 by 3. Because these dimensions give me my answer. So this new matrix is going to be the same size as this first one. That's not always the case, but it is in this problem. And I need to fill in all those numbers. Okay, who remembers how we do that? This is the thing that you gotta be really organized when you do it. How do you do it?
Like say the first row and the
First row, first column. Because that's what spot this is. I'm gonna find that number right there. And that number is in the first row, first column. Remember, it's always rows first and then columns. So we write down all of the numbers in the first row, spread them out, And then next to them, you write all the numbers in the first column. Is this coming back to you?
Yeah. You haven't subtracted, you have them together, right?
We multiply each pair and then
Yeah.
add them up. That's right. Multiply each pair and then add them up. So this one is going to be -2 plus -1 plus 0.
-3.
-3. Then we move over here, which is what? What position is this? Row 1, column 2. So we're still using -2, 1, 4. But now I'm using 2, 1, 3. All right, so we have -4 plus 1 plus 12. So -4 plus 1 is -3, plus 12 is 9. That's exactly right. All right, would you all get that last spot right here? Would you all work on that spot? Let's see if we can all come up with the same number.
Oh, you get -2.
All right, what do you guys come up with?
I got -3.
Got what?
I got -3.
-3,
I got -2.
-2. All right, let's work it out. We have some disagreement. So -2, 1, and 4
I got -2.
times 3, 0, 1. Now, did you write that down?
Yes.
If you try to do too much in your head, that's where you make mistakes. So go ahead and write it down. So we have a -6 plus 0 plus 4. So I think those that got -2, I think that's right. Did you find your mistake, Tom?
Yeah, I found it.
Now, we're gonna go to the bottom row. And the bottom row is 0, 1, -1. So those are the numbers that I'm gonna use now to pair up with each column. So let's do it. Everybody do it. Let's see what we come up with. A lot of zeros in this one, so be careful. And I tend to make a lot of mistakes, so let's talk about anything you don't match on. Is that what you got? Everybody remembers how to multiply? What was that? Was that letter D? So now we're doing E. What does E mean? Inverse. Alrighty. Who remembers the steps to finding the inverse of the matrix. This was on a homework and some of you missed it.
Find
Determinant. Alright, so we do that in Kramer's rule too. So the determinant here would be 3 minus negative 2, 5.
Yep.
Okay, now what?
And then let's do the switch.
We make a new matrix by taking these two
Switching.
and switching them,
Making them negative.
and the other two make them negative, or change their sign. Okay, everybody remember this? Okay, then what?
And then you take the determinant from the previous.
All these get divided by 5. And sometimes we have to reduce, this time we don't. So that would just be the answer. 3/5, 1/5, negative 2/5, 1/5. And last one on this page, A times C.
Can't do it.
Tayshawn?
When we, so on this, it has a line like Eve in the answer. Can we just put like 3/5 and comma -2/5?
No, what you have to, what you put in the answer blank is this right here. You're gonna draw your matrix on the answer blank. What about AC? Can't do it. Cause what are the dimensions of A?
3,
And what are the dimensions of C?
2, 2.
And if we're multiplying, isn't the rule those have to match?
Yes. Yes.
So that would be another empty set. Okay? Next page. Remember, this is exactly what your test is gonna look like. So you got a whole page of matrix operations. Then we've got a big determinant to do. We've done some little ones, like with Kramer's rule and over here for the inverse. But this is a bigger one. He remembers what we do with this
Take the
guy.
first 2 columns.
First 2 columns. And sometimes you guys, you're still forgetting negatives or mixing things around. Don't change anything. Cut it out, paste it here. Cut it out, paste it here. In that order. Then what?
This one.
Start right here. First number I wrote down was 5. I start with that number. So I multiply these together and I get negative 15.
Yep.
And then I multiply these together and I get negative 4. And then I multiply these together and I get 0. And I total all that up. So that is negative 19. If I added right. Now what? Other direction. That is 6, good. That is 10, and this is 0. Remember, anytime you're multiplying by 0, you're going to get 0. So that is 16. What do you do with those 2 numbers?
You can add them.
Subtract them. You subtract them. Remember when you do a determinant, kids, it's this minus this. It's the same concept here. It's this minus this. So negative 19 minus 16 is negative 35. Your answer is negative 35. Alright, now we got a section of basically what I call definitions. What are the dimensions of problem in problem A? What are the dimensions of that matrix? 2 by 4. 2 by 4. 2 rows, 4 columns. Kylie, you with me? You dreaming of the beach?
No.
Okay. All right, if A is this matrix, what is the entry in the 2, 1 spot? That means second row, first column. So yeah, that's 5. Look at it, make sure you understand where we're getting 5. Inside that matrix, row 2, column 1. In the expression 2A, where A is a matrix, 2 is called a
Scalar.
Oh, very good. 2 is called a scalar. A scalar. Very good. What is a square matrix? Well, an example would be a 2 by 2, but that's not really a definition.
When all the dimensions are the same.
So when it has the same number of rows as columns, right? So 2 by 2 is an example, so is 3 by 3, 4 by 4. But the definition is the matrix has the same number of rows as columns. Doesn't that make sense to you, kids? Square, same number of rows as columns, 2 by 2. And then I promised you on day 1, this would be a test question. It's on every practice test, it's going to be on the test. Define matrix. A matrix is a rectangular array of numbers arranged in rows and columns. That's it. That's the definition of a matrix. A rectangular array of numbers arranged in rows and columns. When we finish this test, we'll be done. So let's get it done. Here we go. Number 1, or number 7. Gonna have one of these on your test. So look, this whole page is one problem, and this time we're doing hamburgers, hamburgers and hot dogs, and we are making a number. Oh shoot, it's another fixed interval. It's all right, I'll help you with that. And profit. All right, let's do the part you know how to do. Okay, let's do the part you know how to do. So what can we fill in? To stay in business, he must sell at least 10 hamburgers, but he can't cook more than 40. So hamburgers have to be in between 10 and 40. Would you agree with that? Always graph your fixed interval. So I'm going to go ahead and put that over here as a constraint because I am going to have to graph that. That's going to have to be in my graph. He has to sell at least 30 hot dogs, but he can't cook more than 70.
38.
So don't the hot dogs have to be between 30 and 70? And I just kind of automatically made hamburgers X and hot dogs Y. We can't cook more than 90 sandwiches altogether. That's the total number is 90. Does everybody see that? The profit on a hamburger is 33 cents, and on a hot dog is 21 cents. And I want to maximize my profit. Okay, so far, is everybody okay? Now, every number is in the chart. There are no more numbers. When that happens, you're done with the chart. Don't start making stuff up and putting it in. If you have your variables identified and every number is in the chart, then it's okay that you've got some empty spots. It's okay. What am I maximizing?
Well,
Yes,
point
33x plus 0.21 Now, I automatically put these up here because fixed intervals are always graphed. What else is gonna be graphed?
X plus Y equals 90.
X plus Y is actually less than or equal
Oh,
to
yeah,
90.
yeah.
And then X and Y are positive, which we don't have to graph those because they're built in, but it's automatic easy points. Are we ready to graph? Okay, here we go. Looking at that 90 and these 40s and 70s, maybe 10 is a good scale to go with. So I'm gonna go ahead and graph this fixed interval. Now these are tricky. We've only done one or two of these. So let's do this. That's an X. Here's my X-axis. I'm using a scale of 10. So here's 10, here's 20, 30, and here's 40. And remember how I did this the other day? There are my points right there, 10 and 40. And then I draw vertical lines. Fixed intervals are bars, like bars of shading. So I'm gonna have this bar right here. And I'm shaded all in here. That's all shaded. A fixed interval is a bar. It's not a triangle, it's a bar. And then, that's red. And then I'll do exactly the same thing with my Y's. So 30, 40, 50, 60, and 70. Now, which way will these go? Sideways? It's gonna be a sideways bar. And I'm shaded in between. So right now, I have to be shaded between the reds and between the purples. Would you agree I have this box right here? So now with my orange marker, I'm gonna sketch this one. So I need to go 50, 60, 70, out here to 90. Just remember how we do that. We cover up one letter at a time. And then I'm gonna connect those. And where is that one shaded? Below? So it's below the orange and inside the box. Maybe while you're on spring break, you can pick up some colored pencils if you don't have any. My shape is that. Okay, so what do I do now? I figure out what all my points are, right? Now, don't panic and don't make this hard, you guys. Common sense. See that point right there? That's 10, 30, isn't it? Can't you tell? That's 10, 30. Alright, so I got that one. What about this one right here? 40, 30? And how about this one right here? 1070. Now these these two, because they're on the diagonal line, they're not like we're horizontal, vertical, or crossing, but they're still easy, because if I'm on this line right here, don't I know my x has to be 40? Isn't x 40 for that point right there? And if x is 40, what does y have to be? 50. Because they gotta add up to 90 if I'm on the orange line. The orange line adds up to 90. So what about this one? What do I know about this point right here? What's his y? 70. So what does his x have to be if his y is 70? 20. Don't make it hard, guys. Fixed intervals make finding the points easy. They're kind of confusing graphing, but they make finding the points easy. All right, here we go. What do I need to do now? Put it in the calculator, and it's going to be 0.33 times the first number and 0.21 times the second. So 0.33 times 10 plus 0.21 times 30. I got 960. And
4031 is,
I got 1950. Is that right?
Yep.
That seems like big, but okay, good. Okay, so 0.23 times 10 plus 0.21 times 70. 18 for that one.
the 4051 is 23%.
Give me just a second. Let me finish this one I'm doing, and then I'll take your answer. For this one, I got 2130. And what did you say this one was?
I got 2370. 2370.
370? Did anybody else get 2130 for this one? And anybody else get this one? Don't just take my word for it, I could have typed it in wrong. Are those okay? Maggie, are they not okay?
Oh, I'm doing my last one right now,
Okay.
so, but I got the 4050 the same as you for $23.70.
Okay, actually, Matthew got that one, but that's fine, yeah, you got it.
I got that one
That's
too,
right,
yeah.
okay. All right,
Yes.
so it's the last thing we have to do. Gotta make a conclusion. Now, we're maximizing, so we're gonna tell this guy to make.
40 hamburgers. Wait,
Right.
40 hamburgers.
Okay, we need to make, we, he, they, she, whatever, we need to make 40 hamburgers and 50 hot dogs for a profit of $23.70. That seems like a lot of work for $23.70. Yep, there's one more and then we're done. I promise I'll shut up. We're gonna do one more. What is the last problem then? This is our calculator problem. When we take our test, it will be calculator, no calculator. This problem will be a calculator problem to help you with all this arithmetic. And of course, this one will be a calculator problem that we're getting ready to do. Everything else you need to do without a calculator. Now, I promise I'm gonna keep the numbers small. We haven't had to do anything with fractions. Now, Kramer's rule, we get fractions, but we don't have to do anything with them. So you should be able to handle everything else without your calculator. But this one is a calculator problem. All right, so it's on a page all by itself, sitting there. Lots of room. What's the first thing you're gonna do? Make a matrix. you're actually gonna have two matrices. You're gonna have one that goes in and one that comes out. It looks like our letters are P, Q, R, S. You do not need to write those down, but I find it helps to keep me organized. So what's my top row?
1, -2, 3, -5, 34.
Perfect. That one's easy because it has everything. All right, the next one is missing what? R. So 2, 1, 0, -4, -16. Make sure you get to 0 in the right spot. All right, what's the next one missing?
The first one.
P, so 0, 1, -1, -1, 1. Now, when we took our quiz, some of you, and I don't remember, maybe it was none of you, but some people did not put the negatives in. And some people put zeros instead of 1. If there is an S there, it's a 1S, right? All right, what's the bottom row?
0, 2, 3, 0.
0, 2, 3, 0, -5.
C.
All right, here we go. Second matrix, over to edit. What are my dimensions? 4 by 5, big one. This is how big your 1 on your test will probably be. Here we go. Are you guys typing or am I the only one typing?
No, I did it.
1, 2, 3, 4. Negatives.
All right, after we get everything all typed in, we second quit. And then we go back in, second matrix, over to math, down to RREF. And then, second matrix, enter, enter. Oh gosh, it's perfect, isn't it? I mean, what I mean is, no fraction, or no decimals. So 1, 0, 0, 0, 0. Yeah, I got -1, 2, -3, 4.
Yes.
So what goes in the answer blank? This is your work. This is what's gonna be down here in all this space. And then there's gonna be an answer blank, and in the answer blank is gonna go -1, 2, -3, 4. If your test question comes out with big ugly decimals, you hit math and then choose the fraction option, and that will take care of it. Nice work, you guys. You've done great considering it's the last period.